Gas laws TDS. This will be the demonstration about the egg in the flask. So I have an egg, I have a flask, and I'm going to try to get this egg into the flask. Well, that's not going to work. I could push on it, it would break. Maybe I'll create a pressure differential so the higher pressure outside the flask can push the egg in the flask. I'm not going to change the pressure on the outside, but I'm going to try to reduce the pressure on the inside. What I'm going to do is take a piece of paper and kind of roll it up like this. And what I'm going to do is light this match right here, light the paper. I'm going to drop the paper in. Now notice it's going to be hot. And even when I drop it in, there's not going to be a pressure differential till I cap it. So I drop this fire in, I put the egg over it, no pressure. Now it's sealed. Now there is a pressure differential. So what happens is the fire went in there. It was still open, but then I put the egg on it and it got sealed. And remember, it was hot when it was open, or I'm sorry, it was hot. And what happened is when the egg sealed it, okay, the flame went out. And when the flame went out, the temperature went down. And when the temperature went down, the molecules moved more slowly. When the molecules moved more slowly, they struck the sides of the container with less force and less often, and that caused a pressure decrease and inside the container. And again, if the pressure is less in the container than outside the container, the higher pressure on the outside forces the egg into the flask. So technically, it's not a pulling or a sucking force, it's the pushing force of the higher atmospheric pressure pushing on the egg, forcing it into the flask. Hopefully that gives you a little bit of help in looking at that demo. Should we get this out of here? I guess we can. Put a little water in here. And this is kind of the bonus part, not part of the lab. I'm going to get rid of some of that water and an extra piece of paper. And I'm like, how do I get this egg out? I think PV equals nRT. If I increase N, which is the number of moles, I'll increase P, which is the pressure inside the flask, and force it out. So, yeah, I don't like that paper on the side. It's going to kind of block things. It's not going to allow me a good seal. Let's get that out of there. Okay. Sorry. Let's try this again. Get rid of these loose paper. Get a good seal. Increase N, then increase P, and out will come the egg. Oh, kind of slow delivery, but there we have our egg. All right, thanks for watching for the Gas Labs TDS demonstration.